Over. Here we're going to be talking about the equilibrium constant. At equilibrium, the concentrations of reactants and products are not equal, but their relationship is constant. So that constant is referred to as Kc. So for a reversible reaction at equilibrium, the equilibrium constant is defined as the ratio of product concentrations to reactant concentrations, with each raised to the power of its stoichiometric coefficient. So remember the general equation for a chemical equation is this here. And the equation to find the Kc value is represented like this. So if Kc is equal to the concentration of C to the power of C times the concentration of D, power of D, so that's the equation to find it there. So the square brackets, they denote the molar concentration in moles per liter. The subscript indicates concentrations are used, as opposed to Kp, which uses partial pressures. We'll talk about that in another video. So the value of Kc indicates the relative concentrations of products and reactants at equilibrium. So a large Kc, significantly greater than 1. If it's greater than 1, it means that there's more product concentrations are much greater than the reactant concentrations at equilibrium. So the reaction strongly favors the products. So a small Kc significantly less than 1 means that the reactant concentrations are much greater than product concentrations at equilibrium. The reaction barely proceeds in the forward direction. A Kc that is close to 1 means that products and reactants are present in comparable concentrations at equilibrium. So if it's about 1, then those concentrations are comparable. Not necessarily equal, but pretty close. So there's some key things about the equilibrium constant. Kc is constant at a given temperature. Changing concentrations or pressure shifts the position of equilibrium, but does not change Kc. Only a change in temperature alters its value. Pure solids and pure liquids are not included in the Kc expression. Only aqueous and gaseous species are included. So the expression is always written as products over reactants, not the reverse. So always make sure that we have the reactants on the bottom and the products on the top. So to summarize, Kc expresses the ratio of products to reactant concentrations at equilibrium, with each concentration raised to its stoichiometric coefficient. A large Kc indicates products are favored. A small Kc indicates reactants are favored. Kc is constant at a given temperature. Only temperature changes alter its value. Pure solids and liquids are excluded from the expression.